All right, so we've talked about adding, subtracting, multiplying, dividing with significant digits. Now let's look at it with our tolerances and our errors. When I add or subtract measurements, I'm going to deal with absolute errors. When I multiply or divide, I'm going to deal with relative or percent errors. Here's kind of confusing part. No matter what operation I'm dealing with, I always add the errors. So let's say I have 1.275 inches plus or minus 5,000ths of an inch. And I'm going to add to that 0.850 inches plus or minus 4,000ths of an inch. I'm adding over here. I do the intended operation with the numbers. So 5, 12, carry the 1, 11, carry the 1, and 2. 2.125 inches. Then I add the absolute errors. This would be plus or minus 4 and 5 make 9 thousandths of an inch. Now I'm going to prove to you that this is an accurate combination of these errors. Because 1.275 plus or minus 0.005 is saying anywhere from 1.270 to 1.280, correct? And this is saying anything from 0.846 to 0.854. If I add this up, I get 1.116 to 1.134. If I did this out, I would get, or sorry, not 2.116 to 2.134. If I did this out into a range, I'd get 2.116 to 2.134. It gives me the exact same range of values. Does that make sense? So I found the minimums, added the minimums, found the maximums, added the maximums. So adding the absolute error when I add or subtract does give me an accurate answer. So if I subtract, so I have 2.720 inches plus or minus 0.006 inches minus 1.365 inches plus or minus 0.007 inches. Again, I perform the indicated operation on the numbers. So I'm going to subtract here. 10 minus 5 is 5. Borrow again. 11 minus 6 is 5. 6 minus 3 is 3. And 2 minus 1 is 1. But I always add the error, the tolerance. So 0.6 thousandths and 7 thousandths gives me 13 thousandths of an inch. Everybody understand how I got to this? I do the indicated operation with the measurement, with the number. So I'm subtracting, so I subtracted those numbers. Then I'm always adding on the tolerance, on the allowance. So I added 6 thousandths to 7 thousandths to get 13 thousandths. Plus or minus 13 thousandths is my tolerance on my result. Just like I did up here for addition, I'm going to prove to you that this is correct. So this one here is saying anywhere from 2.714 to 2.726, right? See where that range comes from? This is saying anywhere from 1.358 to 1.372, correct? Now when we subtract, I just didn't go straight down. The largest possible result would be a big number minus a small number, right? So if I do that, 2.726 minus 1.358, I'm going to get, what, 8 minus 6 is 8, it's a 1. 1.368 would be the largest number. So I got that backwards. Put this over here. And then the smallest number would be when this is small and this is large. So when I subtract those, I'm going to get, what, 2, 4, 1.342. Is that the same range I would get if I just did this out? Yeah. If I did 1.355 minus 13, I get 1.342. If I did 1.355 plus, I get 1.368. Does that make sense, what I just did? So I'm adding or subtracting numbers. I do the indicated operation with the numbers, and then I always add the allowances or the tolerances. Next, what if I'm multiplying numbers? So let's say at 2.345 inches plus or minus 0.006 times 0.734 inches plus or minus 0.005. I'm still going to do the indicated operation with the numbers. 2.345 times 0.734. Which is going to give me 1.72123. Now we're going to have to round that off. 1.721, we're going to round it to the nearest thousandth. No, I'm not worrying about significant digits at this point. But my plus or minus now is going to depend on not the absolute errors, but the relative errors. So I have to turn these into a percent. To do that, it's going to be blank over 100 equals 0.006 over 2.345. Does that make sense? So the absolute tolerance over the measurement, over the desired value, will give me my percent. So 0.006 times 100 divided by 2.345 gives us that is a 0.256%. So this is plus or minus 0.256%. I do the same then for the bottom one here. Blank over 100 is 0.005 over my desired value of 0.734. So 100 times 0.005 divided by 0.734. 0.681. So this is plus or minus 0.681%. What do I do with those percents? Always add. I'm always adding. It's because I'm multiplying. Just because I'm multiplying here, I have to work with the percents rather than the absolute errors. So I combine my percents here. 6 and 1 makes 7. 5 and 8 is 13. Carry the 1. That's 9. So I got 0.937%. That's my percent error on my answer. So how do I get what my absolute tolerance is, plus or minus? I have to now find 0.937%. So 0.937 out of 100 of 1.721. So I will cross multiply and divide there. So 0.937 times 1.721 divided by 100. We get 0.016. So this is plus or minus 0.016 inches in that result. Or square inches, I should say. Inches times inches is square inches. What do you think? Confusing as heck? It can be. I'm going to have you try a couple in your seat just to see what you got. Multiply those, give me the result to the nearest thousandth of an inch, along with the proper allowance or tolerance. And add those two, giving me the result and the proper allowance or tolerance. So this one is, what, 8.540 plus or minus what? Oops, I did that wrong. I added. That's not what we're doing. Sorry about that. Let me get the right operation. 7.34. 8.808. Plus or minus 0.54. Anybody get anything different for the plus or minus? Let's double check it. So I'm going to take blank over 100 equals 0.008 over 7.340. I get 0.109%. Here I'm going to get blank over 100 equals 0.006 over 1.200. Gives me 0.5%. So I add those, I get 0.609%. So then I have to find 0.609 over 100 is how much out of 8.808? Let me try that again. So 0.0354, perfect. How have you got that? Just a couple of you. This one should be a little bit simpler. So 2.075 plus or minus, we just add these together. What do y'all think? Good news, I'll never make you do this on a tester quiz. Bad news, it might be an extra credit question on a tester quiz. This one's obviously kind of easy, so the extra credit question is probably multiplication or division. Okay, I'll give you guys the last 20 minutes here or 19 minutes to work on your homework and stuff, since I kind of cut you short in the first hour.